Okay. Pythagorean theorem. That's not a good square. Hold on. Okay. Let's make triangles out of this. I have not done this in a while. Boom, boom. Something's up there. Oh, I know what's up there. This needs to, because these are all going to be the same triangle going around it. Okay. So these are all the same triangle. Keep that in mind. So this is basically the same as one small square in between, inside a larger square, and then dividing it up into triangles. This is just an interesting question. How do we know that this is a square? This inner one. How do we know it's not a rectangle?
Maybe because all the sides are seen.
Yeah, all the sides, because we know that these are all the same triangle, right? That's how we drew our thing. We know that these are all the same side. So, say C, we know these are right angles. I'm going to use capitals for the outsides. I forget which one is which, but I'm just going to use capitals. Actually, no, because we write it in lowercase, right? I'll use lowercase on the outside. A, B, B, B. Okay, so we know that A plus B squared is equal to area of big square, right? And C squared is equal to area of small square, and the area of the triangle is 1/2 a base times height, AB. So we know that the area of the big square is equal to the area of the small square plus, so the area of this small square plus 1, 2, 3, 4 triangles. So 4 times the area of a triangle. Okay, so that means A plus B squared is equal to area of the small squared, C squared, plus 2AB. We expand this out, A squared plus 2AB plus B squared is equal to C squared plus 2AB. Those go away, so A squared plus B squared is equal to C squared. And this only applies to right triangles because we depended on those for this, right? Because if these weren't right triangles, this would not be the area of the triangle, right? Because you would have your height would be a different thing other than the side length. Okay. So that's number 2. Is there any questions so far? Or is there any? Okay, I guess I kind of want to do them in order, right? So the arc length of a function, I'm not sure if there's a specific drawing you need to do, but let's say we have a function, right? And when we're looking at it infinitesimally small piece of it, we can say that this is dx, dy, dl. Let's blow this up. We get a triangle, dx, dy, dl. And we know that dl squared, right? We just did the Pythagorean theorem. This is a right angle because these are 2 vectors going in perpendicular directions. That's the whole thing about the x and y axis. So dl squared is equal to dx squared plus dy squared. I should probably put so and when we find the arc length, right, we know that integrals are what? Well, what are we doing when we find the arc length? We're adding up dl's, right? And because we're doing this in infinitesimally small spaces, right? We're adding up infinitesimally small things. We're adding up differentials. What we want to do is an infinite sum. So arc length is equal to the infinite sum or integral, the integral of dl, right? And that gives us L, right? So I don't know. I guess another thing you could add to the drawing is like L. So so if we want to have an integral of dl's, right? We could take the square root, right? Dx squared plus dy squared. But the problem with this is, well, we know that dl is always positive, so, but the problem with this is that we have no way to define dx and dy, right? There's no relationship. Well, there is, right? You could say dx dy is equal to 2, so you know that dx is equal to 2 dy, but it's in a square root and it's a lot more complicated to do. So what we do instead is we say, hey, what if we factor out one of these, right? So I'm going to factor out, which one do I want? Let me factor out the dx. So 1 plus dy over dx squared times dx squared is equal to dl squared. We divide by dx, we get dl over dx squared is equal to all of that. And so if we take the square root, we get dl is equal to the square root of 1 plus dy dx squared dx times dx. This is in the square root, but since it's squared, we can take it out. And we know that dx is, well, dx will always be positive because we're never, like, who in their right mind is going to set up an integral where it goes from 4 to 3? But that's actually interesting. That's why sometimes we get negative arc length if the bounds are somehow switched, right? Theoretically, you shouldn't get it, but because we pull out this dx without saying the absolute value, that's why we get negatives sometimes if you like do your integral wieldy. So, and now we can say, okay, integrate both sides. Now we're getting our arc length, right? So arc length is equal to that, which is equal to that. And you can factor out, instead of dx, you can factor out dy to get the other one. Any questions? Okay, let's move on. Okay, what do I want now? I want number 4. This is the circumference of a circle. Okay, so this ties into what we just did, right? R squared is equal to x squared plus y squared. That's this circle. We go from r, negative r, r, negative r. I want the arc length, and then I'm just going to multiply it by 4, just because it makes my life easier. So and we know that, right, our arc length is equal to, so let's find this. So we know that y is equal to r squared minus x squared. So, y squared. So 2y times dy dx is equal to, what was I going to put here? R squared minus, no, the r goes out, right? It's negative 2x. And then what we want to do is divide by 2, so dy dx is equal to negative x over y. And then I feel like I'm doing something wrong here. Am I doing something wrong here? No, I don't think so. And we know that y is our, oh, you know what makes this a lot easier? I'll keep going, but what makes this a lot easier is just saying, oh, since I'm only using the top half, let's just say y is equal to the positive square root. And then it makes it a whole lot easier. But this still works as well. So we know that y squared is equal to that. So I guess I'm just doing it a little backwards, but so I'm just gonna plug in the y, right? And since I'm only using the positive bit, I'll just use the positive square root. Okay. So that plus 1, well, we want to square it, right? So x squared over r squared minus x squared, and then let's add 1. I'm just going to extend it into the fraction, so plus r squared minus x squared. Is there any questions there? Do you want me to write that out a little more? But does that make sense? I just extended the fraction by adding the 1. Okay, so these cancel out. We get, oh, I don't want to do that. There's a search thing at the bottom, kind of bottom. But anyways, arc length is equal to, well, you know what, I'm just going to skip that part. I'm just going to say circumference is equal to 4 times, we want to go from 0, since we're doing this in terms of dx, right? 0 to r, so we're going this way, of r squared over r squared minus x squared dx. And then I guess we would do a triangle for this, right? So rx square root r squared minus x squared theta. I probably should have given myself more space, but we do.
It's just integrating the arc length.
Yeah, multiplying by 4. That'll give you the circumference.
Can you explain why when you're done? Why arc length gets circumference?
Well, what's the definition of a circumference?
And I guess like the outside layer.
Yeah, the length from, let's say we start here, we go all the way around. It's that length, right? And so that's what we're doing with arc length is I'm just going to do this portion of it. So I'm going from here to here with arc length, right? I'm going from here to here with arc length. And then I'm just multiplying what length I get times 4, so that gives us the rest, you know?
Oh, yeah, okay, I see. Thank you.
Yep. Okay, so this is cosine will be that. So let's do secant, right? Secant theta is r over, so let's square that. Okay, that's one piece of our puzzle. Now we need a dx. What's the easiest way to get a dx? Let's do sine. Yeah, sine theta is equal to x over r. R sine theta is equal to x. R cosine theta d theta is equal to dx. Okay, that's the other part. So this is all, so that's equal to, I'm not going to put in the bounds just because I'll convert it back later. I prefer converting it back later. I don't really know anyone who does the bounds. But secant squared times r cosine, so that'll be r secant, right? I'm just doing out the multiplication. Does anyone need to see how I got from here to here, or does that make sense? Okay, so r secant theta d theta, so that's r ln secant theta plus tangent theta plus c. But since we're doing a definite integral, I can just ignore that because it'll cancel out anyways. 4. Oh, I don't want to add that in just yet. Let's remember that we did a 4 here. In fact, I should probably write it over here as well, and here. But, okay. Let's convert these thetas back into x's. Secant theta we said was r, and then tangent was x, yeah, r plus x over, I'm just combining the fractions since they both have the same denominator. And we want to go from r to 0. Well, at 0, this is going to be r over r squared, right? So that's r. Well, you know, I'll write it out. I wish there was a way to drag this so I could. But anyways, for r times ln 2r over r squared minus x squared. Ooh, that is a what do we call it? Indefinite integral, right? So we need to take the limit as t goes to r of 2r over r, shoot, what am I doing? R plus t over r squared minus t squared. Am I doing this right? I am doing this right, correct? I feel like I might be going wrong somewhere, but ln, and then this one is ln, the x is 0, so it's r over square root r squared, so that's 1. That becomes a 0. So this is, because this goes to infinity, so I feel like I've done something wrong here.
You probably don't need the ln's. You can just do it by drawing. Yeah, you can do this without the ln's. That might help you get the right answer.
I think when you integrate secant, you might just like do it like triangle. Like you just plug in the triangle rather than doing it then.
Wait, what are you saying? Sorry, are you saying just convert the bounds? Is that what you're saying, or did I do the triangle wrong? Oh, secant times. Wait, sorry, keep going. Sorry.
No, I think I'm also.
Secant theta. Secant is opposite or hypotenuse over adjacent. Square that. R sine theta. X r cosine theta. Ln secant plus tangent. Well, this in itself is also an indefinite interval, so I feel like maybe I did go wrong somewhere, right? Because you can't plug in r into this, so maybe my setup is wrong. So that means y is equal to the square root of r squared minus x squared. So dy dx is equal to times, what are we multiplying this by? Negative 2x. Okay. And then we go negative x over. Yeah, so that's right. And then it becomes x squared plus r squared minus x squared, r squared, rx.
Yusuf is asking if we should square rooted the integral. He doesn't have a mind.
Oh, where did he say that?
For the integral.
So for the integral, if I should have what?
So I think that for the arcade we it's like square root of all that, right?
Yeah, never mind. There it is. Okay, so yeah, so dy dx plus 1. Whoops. Okay, let me do that. Come on. There we go. Okay, so it's not this. It is.
The triangle was good though. I mean, up until there is good.
We want the square root of this though, right?
Right.
Okay, so this will be, let me rewrite this. This will be r over square root. Okay, yeah, that's where I messed up. Whoops, my bad. Rx square root. I'll just do this quickly. So we don't want this. We want this. Okay, okay. Well, then now it is just r d theta. So that's 4r theta. And theta is, and I should put the bounds there. That's going to be a mistake. He'll probably mark you off if you do that, you know. So 4r theta. What's the easiest? Let's do sine inverse. That's probably the easiest. Sine inverse x over r. 4r from r to 0, which is equal to 4r sine inverse 1 sine inverse 0. So that's 0. Sine inverse 1 is pi over 2. So that is 2 pi r. Boom. Okay. Any questions there? Or kind of went by that fast, and I also messed up, but does that make sense? Okay, cool. I will go to the area of a circle, which I think is much easier. Let's see. Okay. Area of a circle. Well, I'm going to do a quarter and multiply it by 4 again. This will be r squared is equal to x squared plus y squared. So y is equal to the square root of r squared minus x squared. And we want to do this interval. Does anyone need me to show how I set up this interval, or I think we'll be fine. 0 to r, and then we want to multiply that by 4. Okay, so this is another triangle, I think. So this is 1 over r secant theta is equal to, that's one piece of our puzzle. And we want a dx, so that's r cosine theta. I'm just kind of like skipping through this part because we did a lot of this with our arc length, but that's that. So this is just d theta, or which is theta, which is sine inverse. Wait, this is just gonna give us. Okay, probably did I mess up here again? Because 1 over r secant theta. Because this, I don't know if this is gonna give us what we need.
This should work. The setup is correct.
Sine inverse x over r, so sine inverse 1 is pi. This gives us 4 pi, because this is basically the exact same. Oh, yeah, because we're looking for r squared minus x squared, not 1 over r squared minus x squared. So r squared minus x squared is equal to r cosine theta, right? This is what we were looking for, not 1 over. And then r cosine theta d theta is also equal to dx. So there's our puzzle. And so this is 4r squared cosine squared theta d theta. Well, cosine 2 theta is equal to 2 cosine squared theta minus 1, double angle. So cosine 2 theta plus 1 over 2 is equal to cosine squared theta. So I'm going to put the 1/2 on the outside, so it's 2r squared cosine 2 theta plus 1 d theta. So this is sine 2 theta over 2 plus, this is a 2, plus theta from r. Oh, you need to convert this still. Sine 2 theta is also 2 sine theta cosine theta, so this is just sine theta cosine theta plus theta. Sine theta is x over r, cosine theta is that over r. So that's x square root r squared minus x squared over plus theta, which is sine inverse x over r. I'm kind of running out of space here, but so that's the definite integral. This, when we plug in r, so this is going to be 4r squared. When we plug in r, this will be sine inverse. This will be 0 because r squared minus x squared is going to be 0. Sine inverse 1 is pi over 2. And then when we plug in 0, this is going to be 0 and this is going to be 0. So this is equal to, which is 2 pi r squared. I messed up somewhere again, because we should be only getting pi r squared. Cosine squared, cosine 2 theta. Do I need to multiply by 4? Yes, I do. R squared minus x squared is cosine over r cosine theta.
The inverse sine of negative 1 is negative pi over 2, not 0.
Inverse sine of negative 1. It shouldn't be negative 1 because it's sine r over r, right?
Wait. I see what you did.
Oops, did I do something wrong? 4r squared 2 pi r squared. The interesting thing is I'm just getting double my answer. So if we go from negative r to r, it gives us the right answer. So I'm just wondering why if we only go from 0 to r, all of a sudden it doesn't. Actually, right, because if we go from negative r to r, then this becomes negative pi over 2. But then we don't multiply by 4. So that gives us, we multiply by 2. So then that gives us pi r squared over 2. Okay, I'm doing something wrong here, but I just... 4r squared.
Is this the area question?
Yeah, this is the area.
I think for this one you have to use parts.
Parts? How would you do parts on that?
Cause I did this one a while ago, but I think I got like cosine. I got r cosine theta and for one of them, and then something cosine theta for the other one. So I got r squared cosine squared theta, and then I had to do parts for cosine squared theta.
R squared cosine squared theta. I feel like...
I can do it real quick and send it.
Yeah, you do that. I'm just gonna keep looking at this because we're off by a factor of 2 here, which makes me feel like this is wrong, but that doesn't seem wrong because we're going from 0 to r. F of x dx cosine squared theta r squared in front. Cosine 2 theta plus 1 over 2 r squared. Oh, no, I didn't do, okay. We went from 4 to 2, and then I went back to a 4 over here. This should be 2. Does that make sense? So that's a 1. Okay, does that make sense? Okay. I guess I'll move on. Which one are we doing next? Circumference. We did that. Area. We did that. Volume. Okay, so let's do volume of a sphere. Volume of a sphere. So again, let's okay. If I just revolve this piece over here, do I have to multiply if I start from 0 to r? What do I have to multiply by to get the full volume? Can you guys hear me or no?
Or can you say that again?
So what I'm gonna do is I'm gonna revolve to get the volume of the sphere. I'm gonna revolve the circle from 0 to r. So if I revolve it from 0 to r, what do I need to multiply it by to get the full volume of the sphere?
It's root r squared minus x squared.
Well, yeah, but I'm just saying, like, once I get my answer from 0 to r, what do I need to multiply it by to get the full volume?
Oh, multiply by 2.
Yeah, not 4. I remember someone did that last year. So it's multiplied by 2. Okay. We could do this by shell or disk, but I think disk will be easier. R1 is equal to y, which is equal to the square root of r squared minus x squared. We don't need the negative, right? We just want the positive. The reason we don't need the negative is just because we're going to revolve the top. So we want to do pi r squared dx from 0 to r. R1 squared is r squared minus x squared. Okay, this one's not too bad. R0 pi, that's r squared x minus x cubed over 3. R0, that's r cubed minus r cubed over 3, which is 2r cubed over 3 times pi. So 2 pi r cubed over 3. And I forgot to multiply by 2 at the beginning. So 2, 2. This is multiplied by 2, so that becomes 4 pi r cubed over 3. 4/3 pi r cubed. Does that make sense? I think so. Yeah, I got the Derek, for the two statements for 24 and 27, I sent those to Ashish. He also asked. Let me see what those are. So for 24, it's include the statement is that you're explicitly trying to find the zero of a function, if that makes sense, right?
So I would just straight up write that?
Yes,
Or-
I'm trying to find the zero of this function.
Okay.
And then
And then
for 27, you want to say that the rate of change of y is proportional to the value of y. So that's why dy dx is equal to k times y, right? You need to establish that that's what growth is. Growth or decay, I guess, right?
okay, gotcha. Thank you.
Okay, let's move on. Volume of a sphere. We want to do volume of a cylinder now.
Wait, sorry, what about the statements for 24 and 27?
So I'll get to those, but if you know what those are, which I'm assuming most of you do, Newton's approximation is we're trying to find the zero of a function. So say trying
Right.
to find the zero of a function. That's the statement.
Mm-hmm.
And then for 27, at least I think that's the statement. You should always confirm with your teacher because I haven't done these in a while. But that's the only thing I really wrote down for 24. I don't remember.
Got it.
But 27, I know for a fact that one is the rate of change of y is proportional, right? So the rate of change of y is proportional to the value of y. And then you solve, right?
Mm-hmm.
So that's your statement, right? Because so you say continuous growth or decay is when the rate of change of y is proportional to the value of y.
Got it.
Okay, so volume of a cone. Does anyone, because I don't know if I want to go through all, I mean, that's kind of all we're here for, I guess, but does anyone want me to go through the volume of a cylinder? Does anyone not know how to do that? Because I can do it, but I just want to make sure that people actually need it. So, I can't. Okay, all right. Volume of a cylinder. Let's do that. Volume of a cylinder is. I bet the easiest way to do this is okay. Let's say we have a line that's going this way. This is x is equal to r, right? So that this is r, and then y is equal to height, so that this is height, right? So if we revolve this, this is, I would personally do it this way and make this h and this r, but for the sake of looking nice, I'll do it this way. So if we revolve it this way, we get a cylinder, right? So r1 is equal to x, which is equal to r. So pi, and we were going dy because I'm doing it around the y-axis. So I'm adding this that go upwards. So that will be pi r squared dy from 0 to h. So r squared x h 0 pi. So then that's pi times r squared h minus 0 because r squared times 0 is 0. So that's pi r squared times height. I don't remember if squeeze theorem was on the thing or not. Generally, if it's not on that sheet, I really doubt he's going to ask you it. On the theory final, he will ask you squeeze theorem. I think he did that for both finals. But for the derivation final, I don't think he will. If you want me to go through it, I can try going through it. I haven't done it in a long time. I remember on both theory finals, that was the one thing I missed. So, but I can try going through it. Okay. What else is there? Volume of a cone. Does anyone need me to do cone? It's very similar, you just do a line instead. But I can do the cone as well. Does anyone want me to do the cone?
Can you do surface area of the
Surface area of and what?
sphere?
Ellipse? Is that what I heard? Sphere. Okay, sphere. I can do sphere. Did I skip over that? Let me see. What number is that? Sphere. Oh, I will get to that. Let me just ask the other ones. Does anyone want me to do cone? Volume of cone? Okay, does anyone want me to do volume of an ellipsoid? It's very similar, but okay. Does anyone want me to do volume or surface area of a sphere?
You do it?
Which one? Surface area of a sphere. Oh yeah, you're the one that wanted that. So let's do that. Surface area of sphere. So remember that surface area is 2 pi r times dl. I still don't know why we do a dl instead of a dx, but we do a dl. So y is equal to square root r squared minus x squared. So that's really only the upper half. So let me draw that. I'm using the upper half of a circle, and what I'm going to do is I'm going to revolve the surface of that sphere. So we know that r1 is equal to y, and that's equal to r squared minus x squared, and then dl. So that's dl is equal to square root of dy over dx squared plus 1 dx. dy over dx is negative 2. Is it? No, it's negative x over plus, there's no square root down there. So that's r squared over, but then we square root that to get dl. So this becomes 2 pi times the square root of r squared minus x squared times r squared over the square root of, sorry, there should be a square root up there as well, right? So this is, I'm kind of skipping over a lot of steps. Let me know if anything is unclear right away. That way I can just go back and fix it. Is anything unclear so far? Okay, so so these cancel out, so it's r dx. Oh, and our bounds for this is 0 to r. That's a good thing, because we actually have to multiply this by 2 as well, so there's a 2 here. So this becomes 4 pi r dx from 0 to r. So that is, oh, I heard a question. What?
Multiply by 4.
Repeat that. Sorry, it was choppy.
What did you multiply by 4?
Why don't, okay, that's a good question. It's because we're taking this strip of surface, we're revolving it, right? And so we're getting the bottom half of this strip of surface. So if I didn't multiply by anything, what we're getting here is half of the surface area of a sphere, right? Because we revolved it. So whenever we're revolving, right, you have to be careful about, okay, what am I getting without multiplying anything? Does it make sense why when we revolve we're getting half of it? Because we used a fourth, right? Oops. We used a fourth, and then we just revolved it. So now we got a half. Does that make sense? Okay, good. So now that's why we multiply by 2 when it comes to the volume and surface area.
So is there?
Oh,
Yeah,
sorry.
I couldn't use that just.
Sorry. Could you say that one more time?
Yeah, so for surface area for any shape, do we always have to do 2 pi times radius times the function? Wait, times the arc length?
For any surface area, it's 2 pi r dl. Is that,
Okay, and we're just multiplying by 2 because we only did half of it.
yeah, and then we're multiplying by 2 again because we only did half of it for this specific problem. But it's always this for any function because 2 pi r is the circumference of a circle. And then we multiply it by dl. Don't ask me why we multiply by dl. I don't know. It makes more sense for dx for me, but it just doesn't work.
Got it. Thank you.
Okay, so 4 pi r.
It's basically integral of 2 pi r times arc length.
Yeah, times the arc length. Because
Okay.
I don't know. I think that when you do a circle or any curved surface, if you just use the x's, you're losing a lot of information versus if you use a dl when it comes to arc length and surface area specifically, but I don't know. So what was I going to say? Okay, so rx r to 0 for pi. So that's r squared minus 0, so 4 pi r squared. That's the surface area, right? Yeah. And a good way to check is the derivative of the volume of an object, or actually it might only apply to spheres, so I don't want to say an object in general. But the derivative of the volume of a sphere is the surface area of a sphere, and the derivative of the area of a circle is the circumference. So for a sphere, volume is equal to 4/3 pi r cubed. So surface area is equal to 4 pi r squared, right? And then area of a circle is pi r squared. So the derivative is 2 pi r. I think the reason for that is, I don't know. I don't know what the reason for that is. Area, circumference. Because it could be that we're taking it with respect to r. I don't know. I don't know what the conceptual reason for that is. I'll have to think about it. But that's a good way to check. So we know that this is correct. Okay, what's next? Sphere, ellipsoid, average value of a function. This one's pretty cool. Wait. Oh, does it just mean, okay, I know what it means. So the way we define the average value of a function is we have a function. We want to find the average value from a to b. I guess the average will be like somewhere here. And so the area of the function is equal to the average value times the distance, which I'll put as capital B, right? So the average value is the rectangle that you can create so that it equals the area of a function. And I think the reason for that has to go with, I mean, if you think about how we compute area normally, right? We'll say, I don't know, Bob has 1 apple and Sally has 3 apples, right? So it's actually, when we do, okay, I just realized this, but when we do the average for like statistics or whatever, right? How we normally do average is just like a Riemann sum discrete version of this, right? Because we'll take the area of this, 1, plus the area of this, 3, divide by the base, 2. Right? It's just a Riemann sum. It's like a Riemann sum of the definition of the average value. So, yeah, I guess that's interesting. And it doesn't matter. You might be wondering, okay, why do we say these are ones? Well, we could make each of these, as long as they're equal base lengths, we can make this whatever we want, 1/2, 1/2. It doesn't matter, right? Because then it'll be 1/2 plus 3/2 over the distance, which is 1, which is same as this. Doesn't matter what you pick for the base of your rectangles as long as they're all the same. So, I don't know. I thought that was interesting. I just realized that. But anyways, so we know that's that. Is that all wait. What is it? What is it asking when it wants the average value of a function? Is that it? Do you guys know what we're supposed to do for this?
I think it just, like, you set area equal to the integral of f of x from a through b, and then base is just b minus a, and then you solve for f bar of x.
So f bar of x times b minus a is equal to Is that what you're saying?
Yeah, from A through B. You said the bounds from A
Oh,
through
yeah,
B.
yeah.
Yeah, and then you just solve for f bar of x.
Oh, okay, okay. I guess that's, yeah. It's nothing too complicated. It's just a more explicit version. Okay. So that's that. Average value integration by parts is just the product rule, but kind of in reverse, I guess. So, if you have two functions, let's say u and b are functions of x, right? D over dx of u times v is equal to du. I haven't done this with this notation, so I don't know how well it'll go, but we'll see. Times dv dx times u, and this is a plus. And we can cancel out all the dx's by multiplying by dx on all the sides, which makes sense conceptually too, because if you think about it, it doesn't matter as long as they're all related with some variable. It doesn't have to be x, it can be y, it can be z, it doesn't matter. So we just turn this into an absolute derivative, right? And now we say, I guess I'll go back to prime notation now that kind of already a little notationally weird. U prime of v plus v prime of u is equal to, so I don't know, do this, right? Am I tripping? This is what we do, right? So then we just see, this is why I don't like prime notation, because now it's like, okay, well, what do you integrate with respect to? Does he make you put something here? I think he just puts an integral symbol. The reason is, if you actually did it with this notation, you could say dx. So that's why there's that weird, like, why isn't there no d anything here? But anyways, what was I gonna say? Okay, so u prime of v is equal to ub, right? This is ub minus v du, right? Oh, because I flipped them. Whoops. Well, if you solve it, you'll get u dv, so u v prime. Oh wait, he does. Oh my gosh. Okay, I'm going all over the place. He does do it with this notation, right? That makes it at least a little bit more bearable. So u v is equal to so u dv is equal to u v minus v du. Does that make sense? You don't even have to say this. I would do it anyways. Just because they need to be related functions. But almost all functions you can make related just by making up a variable, so it also doesn't really matter. But whatever. Anyways, yeah. So I guess if for shower, I guess you can just skip all this and just say this. There it is. Okay. What's next? Average value, integration by parts, arc length of a sector of a circle. Oh, so this is pre-calc, right? We do arc length of a sector of a circle. So we have this, theta. Well, the ratio of full circle angle, 2 pi over theta, is going to be equal to the ratio of the arc length over the full arc length, which is 2 pi r. Other way around, whoops. Right? These ratios are going to be the same. we're gonna put here s. So s times 2 pi is equal to theta times 2 pi r. So theta r is equal to s, right? R theta, I think, is, let me say it this way. Okay, that's that one. Do you guys need me to, actually, I'm going to go back to asking you guys because these are kind of tedious. Do you guys need me to do the area of a sector of a circle? It's very similar. I don't think you guys need it, right? What about the quotient rule for derivatives? Do you guys need me to see that? Oh, I think someone sent something in the chat. Okay, no quotient rule. What about product rule by limits? Do you guys need to see that?
Yeah, let's do that.
Okay, product rule. Okay, so let's do A and B. Actually, let's do F and G. So, do we want to do F and G? We might want A and B. So F prime of X is equal to F of X plus H. So A of X plus H times B of X plus H minus F of X all over H. And so we're going to lie and compensate up here. So we're going to say A of X plus H, A of X plus H times B of X plus H, come on, minus A of X plus H, B of X, I think this works, plus A of X plus H, B of X, minus A of X, B of X. This is all over H. So now I'm going to do a little bit of separating, I think. Where should I separate? I think I can separate right here. So both of these will have H. So I'll say, for this one, I'm going to factor out A of X plus H. There should be a plus and minus somewhere. This is a plus. I guess I got hidden by my slash. Plus limit as H goes to 0. Okay, what's this as the limit H goes to 0? It's A of X. And what's this as the limit H goes to 0? That's B prime of X. And then what's this as the limit of B of H goes to 0? That's also just B of X. And then this as the limit as H goes to 0 is A prime of X. So there you go. Product rule. Okay, what else do we want? Oh, we want to... Oh, he's gone. I guess he wanted 22. Okay, do you need to see ln or log of X?
Yeah, what?
Do you need to see
Um,
ln or log of X? Or...
Um, can we see the Newton's approximation?
Okay. Newton's approximation. So this one, it's important that when you make your drawing, he wants it set up a certain way, and honestly, it should be set up this way, because if you don't set it up this way, then it kind of just shows you can draw whatever function you want as long as it hits the x-axis. And to make it easier on us, I think most people just draw this. This is the easiest one to do, easiest drawing to look at. So, and then by the way, Yusef, we'll go to 22. After I show him Newton's approximation, I'll go back to 22. So, our statement for this is we want, at least I think this is a statement. I don't even remember writing down a statement on my derivations final for this, but okay. So this is x0, right? This is our initial guess where we're like, okay, I picked this number. It gives us something kind of close to 0. And then we want f of x 0, right? That's the other part of this point. And then what else do we want to do? And then if we make a line out of this, this point over here is our second order of approximation, but we just call it x1, f of x1. And then what we want to do is we want to say, okay, well, y minus x0, we want this line, right? We want this line over here. I'm not going to call that y, but we want this line. So let's write out this line. Y minus x0, f of x0 is equal to f prime of x0 times, because this is our slope of our line, times x minus x0. So now this is our line. Well, we know that this is a point on the line, so why don't we just plug it into our line and then solve for what we want, which is x1. So f of x1, which is 0 by the way, so that's 0, minus f of x0 is equal to f prime of x0 times x1 minus x0. So then that's x1 minus x0 over minus f of x, well, on this side it's minus f of x0 over f prime of x0. So then we add over the x0 and we get x1 is equal to x0 minus f of x0 over f prime of x0. And then that's our Newton's approximation. Okay, is there anything else we need to see? Is there anything else you want to see, or?
Can you do the next one, the antiderivative as an area?
Okay, yeah, this one's my favorite. This one is really cool. Let's do that one. Okay. So, I mean, the rationale for this is that, okay, well, I know that the area, right, from, oh, this is very tilted, hold on. I know that the area of this function from x to x plus h, just two numbers, right? I know that the area, oh, this is not good. Boom, 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 boom. I know that the area of this is equal to the infinite sum of rectangles. But I mean, that doesn't really help, right? But through this derivation, we know that the infinite sum is equal to the integral. So that's what we're trying to prove. Well, let's pretend that there was this. I'm gonna do colors for this just because it makes a little more sense. So the blue is the area I want to find, right? Actually, okay. This is gonna. So I want to. So let's say there's this function a of x, which gives me the area from 0 to x, right? Well, if I take the area from 0 to x plus h, right? So a of x plus h minus this extra stuff is equal to, I should probably put these, is equal to our area that we desire, right? So that's equal to, I don't know, big A, right? And our big A is equal to, which we showed, which we know that it's equal to the average value times our base, which in this case, do you know what that base is? Oh, and then by the way, we'll get back to 22. I saw that you left, so I wasn't sure if you still wanted it, but we'll get back after this. So what did you? So do you know what the base is for this?
H.
Yeah, so it's H. So then we know that that's H. So we know that we combine these two. We know that A of x plus H minus A of x is equal to. Okay, let's divide by H. And so we know that's our average value of x. Well, what if we take the limit of both sides as h goes to 0? What does this become?
The A prime.
And then what does this become? This one's really cool. What does this one become?
It approaches f of x, right?
Yeah.
Like this.
And there's two ways you can think about this. I always thought this was cool. Is that like, well, once these two lines get close enough, right? The average value is basically just going to be your f of x, which is, but then you can also think of it like, well, we write it like this, but it's more like, right? And, right, because you need two values to find your average. So as b gets closer to a, or as, I'm going to write these as x and x plus h, as x plus h gets closer to x, you're finding the average value of x and x. That's just x. Well, that's just f of x, right? So that's another way to think about it. But anyways, you know that the derivative of your area is equal to your function, so is equal to f of x dx. So that's that derivation. Okay, let's go to 22.
Do we have to like put as a statement like the as f bar of x approaches, or as h approaches 0, f bar of x approaches f of x, or can we just leave it like the way you put it?
I would write it. I mean, it's on a test, so writing it doesn't hurt. So I would just write it.
Okay. And then for 22, honestly, I just like I get the um I get how we get up to what is it 1 over x log of e, but I was just wondering if we can leave it like that, or do we have to, because someone had sent their work and they like went beyond just 1 over x log e. Do you know if
I
we have to
mean,
do that, or can we leave it?
I don't think I haven't done the derivation in a while,
Okay.
but I don't think I've gone past 1 over x log e. What do you think? Do you remember how they got back? They went past it. I mean,
No, but I can check really quick.
okay. While you check that, I'll just
I
go through
think
the
they
derivation.
did. Uh, I found it. I think that what they just did is they did like y equals log e, and then made it like ln of 10. Oh, they did 1 over ln of 10 instead of log e.
1 over. Oh yeah, because that's just uh, well, log 10
Isn't
is
that the
equal
same
to.
thing? I feel
Yeah,
like,
they're the exact same thing. Because you know how I know a lot of schools teach it this way. Log base a of b is equal to ln b over ln a, right? So
right.
log base 10, right? Because we're doing base 10 of e is just ln e over ln 10, which is 1 over ln 10. So he just did that expansion. And he showed this because this is, remember how our school lets it 10 to the y is equal to 10. So ln 10 times y is equal to, and this should be e, sorry, this is e. So that's
Do we
why.
have to do that though? Or
Uh,
can we just leave it as log e?
I mean, it doesn't hurt to do it,
I can probably just,
but I don't think you have to
okay.
do it because I don't think I did it. But oh, wait, uh, wait, because no, I think you can leave it. because I was about to say like, oh well, we are trying to prove something about log x, so it doesn't make sense to have log in our answer. But we're trying to prove the derivative, so it's assumed that we know how to calculate the actual function. So that's fine.
Okay.
Okay, so let me go through this
Hey,
derivation.
are you doing these in order, or are you just like doing what people ask?
I was gonna do them in order, but honestly, I feel like a lot of these quadratic formula.
Yeah.
We've never done that.
Yeah, that's what
Whoa, what? What used to be there? I'm trying to remember.
for the quadratic formula.
Yeah, what used to be number 30? I'm trying to remember because we had a different one. We never did the quadratic formula.
Well, that was originally Pythagorean theorem, but he
Oh,
put
okay.
it somewhere else. He put it number two, so
Okay,
then
could you guys, okay, I'm
just
gonna, let me do 22 and then I want you guys to show me how to do the quadratic formula because I haven't done that.
okay. I get 22 though, so you don't have to do it unless
Yusef wants
someone else
22,
had asked.
so I'll just do that real
Oh,
quick.
okay.
You don't have to. I was asking for him, so you're good.
Oh,
We're good.
okay, alright.
Yeah.
Alright, can you guys show
So
me the quadratic one because I didn't do that one.
I honestly didn't know it was even there. I just realized that we crossed out Pythagorean and put quadratic. So yeah, I
Oh,
don't know.
do you know how to do it?
Well, someone sent their work for that one too, but I wasn't sure if that's how he wants us to do it. But um, I don't know.
Okay, do you
Maybe
want
you
to
should.
send the work? I'll look at it. If not, that's fine, because, well, actually, this is going to be on your test, so I should figure it out. Let's see.
Let me find it.
Do you have the picture? Or do you want us to send it?
I don't have the picture, so if you guys could
All right,
send it, that'd be
I'll send it in the chat.
okay.
I put it.
Yeah, he put it out there.
Oh, is it in there? Let me see. Okay. Um, 0 is equal okay, and then negative c over a. B squared. Um, plus b squared over 4x. I'm okay. I'm trying to figure out because they go from negative c over a is equal to x squared plus b ax, which I get, and then they go to whatever comes after that. And I'm trying to figure out how.
I think that like there was a made a mistake. Like they said plus four.
Oh,
They
I
meant
see
to
where. Yeah, I
add
see where
these.
the mistake is. Okay, this is an inch. Okay, I've never seen this before.
They
So
just they said 4x² by accident.
yeah,
So.
yeah. Okay, so I get it. And they also did another. Actually, did they? No, they didn't do another mistake. So, anyways.
Yeah.
Okay, this is okay, I've never seen this before. So ax squared plus bx plus c, right? Because we want to find the 0, and we move the c over. Dang, this is such an elegant. I didn't realize like it was this simple. But negative c over a is equal to x squared plus b over ax, right? And now we're gonna lie, or actually we're not gonna lie. This is an equation, so we're just adding stuff to both sides. So plus b squared over 4a squared, right? We're basically adding b over 2a squared. And I guess an easy way to remember why we're adding that is that's the vertex, right? Or negative b is the vertex, but because we're squaring it, we're keeping it positive. But that's the vertex. So actually, that doesn't really help remembering. But anyways, I guess it's interesting to note that's vertex. And then what do? They turn this into one fraction. So b squared minus 4ac. Oh, I see where things are starting to come. 4a is equal to, and then this is, yeah, because if we say that, so this is x plus, no, wait, 2ab, 2ab. Well, if we say our first term in our binomial is bx, and then our second term is 1 over a. No, because our first term just has x squared. So we know that our first term, I'm trying to fit this into a quadratic. We know our first term is x, so our next term has to be b over 2a, right? So that it's a squared plus 2ab, right? 2ab will be 2 times b over 2a times x, which is equal to b over ax, and plus b squared. So I guess I didn't even need to think about the middle. I could have just looked at the sides. But yeah, okay, so we know that that's equal to that. So now we, wait, where do we go from there? Do we just square root and then subtract? Oh yeah, because basically once we set this equal to 0, we're finding x, right? So that's what we're going to do, is we're just solving for x. So square root of b squared minus 4ac over 2, wait, over root 4a. Is that a 4a squared? Yeah, it is a 4a squared. Okay, that's where. Yeah, okay, that's a 4a squared. But anyways, so now when we take the square root, it's b squared minus 4ac over 2a plus or minus, right? Because we took that square root ourselves, is equal to x plus b over 2a. So then that's b plus or minus the square root of b squared minus 4ac minus b, because we're moving this over onto this side, all over 2a. Does that make sense? So basically, we have a quadratic form. We set it equal to 0. Then we move c over, and we add something that can make this into a quadratic, and then we go from there. Does that make sense?
Wait, real quick. How do you go from like the third line to the fourth line? Kind of confused.
From here to here.
Yeah. Yeah.
On both sides, so we start with negative c equals ax squared plus bx, and then on both sides, because it's an equality, I can add b squared over 4a squared. And why we add b squared over 4a squared? Honestly, I don't know. I know it's the vertex squared, right? Minus b over 2a squared is equal to this. But as for why we add the vertex squared, honestly, I don't know. I guess someone must have had some insane forethought to think that it would keep going after that. But yeah, so that's what we do, what I did. And then I turn this into one fraction here.
Wait, so how did the negative c become negative c over a?
Okay, I see. So so you see up here, I first divided by a. So negative c over
I see.
a is equal to, and then I added to both sides what I needed to. Does that make sense? I guess I skipped it.
Yeah. No, you're good. You're good.
Okay. Any other questions? Is there any other ones you're iffy on, or?
Real quick, can you go over 8 and 10 again? So the volume of a cone and the surface area of a sphere.
Okay. Yeah, I can do that.
Thank you.
So volume of a cone. So with the cylinder, we used 2 lines, right? So when we did our, oh, come on, there we go. When we did our cylinder, we did R and H, 2 different lines. But with the cone, we're just going to use a single line that crosses. Come on. Okay, yeah, right? So this line would be y is equal to, we know that the slope is negative r over h, because every time it moves h to the right, it goes down r plus h. Does this make sense? There's obviously you can do it out, right? You can say, well, the slope is, this is h, this is 0 comma h, this is r comma 0, and then find the slope and do it that way. But does that make sense so far?
Yes.
Okay. I kind of messed up here because if I want to revolve it properly, I'll have to revolve it across the y-axis, which I don't want to do because that's more work. So I'm just going to flip. I'm going to switch R and H right now. Let me do that. Oops. Come on. So this will be H.
Could it be easier if we were like a positive slope? So it goes from 0 to r
Yeah,
comma h or h.
that's also another thing you can do actually. Will it be easier? Well, why do you think it would be easier though? I think it would be the same, right? Or am I?
No, because then you don't have to worry about like any intercepts, like any y-intercepts. It's kind of just
Oh,
um,
that's smart.
just
Yeah. Oh, I see what you're saying. Yeah, that's way better. Okay, let's do that. So let's say that this is H and this is R. So this is like a sideways, right? We're gonna revolve it this way, so it's gonna be a sideways cone. So let's revolve it. We get R1. Y is equal to moves R H, so R over HX. So we want the volume. Yes, we want the volume. Okay, so pi times R over H x squared dx. Pi r squared dx from 0 to h. So r squared over h squared times pi times the interval of x squared dx from 0 to h. So that's x cubed over 3. So that's pi r squared over 3h squared times the definite of 8 from 0 to h of x cubed. So that's h cubed times pi r squared over 3h squared. That's h. So it's pi 1/3 times pi r squared times height. 1/3 pi r squared times height. Does that make sense? Okay. Then what was the other one? Surface.
Wait, real quick. Sorry.
Yeah.
Why did you square it? Why did you square y?
Because when we want the volume, what's the area of a circle? It's pi r squared, and we're adding up a bunch of circles, so it's an infinite amount of these. Our volume becomes an infinite amount of these times dx, right? Dz.
Oh, I see.
Right.
Okay.
So the r is this. We squared it.
Okay. Thank you.
Yeah.
Can we do 10? The surface area of a sphere?
Yeah, I can do that.
Thank you.
That one is, I think, one of the quicker ones. Let me see. I'm gonna do a half circle because I'm gonna revolve it anyways. Y is equal to the square root of r squared minus x squared. We want the surface area, so let's revolve the arc and multiply by 2 because I'm only gonna do this half from 0 to r. R1 is equal to y, which is equal to the square root of r squared minus x squared, and the surface area is 2 pi r times dl, and we do an infinite of r dl. So that's our r, we want our dl. dl, since I'm going across the x-axis, I want it in terms of dx, so that's square root of dy over dx squared plus 1 dx. dy over dx is negative x over square root r squared minus x squared. So that squared is x squared over r squared minus x squared plus 1, which is x squared plus r squared minus x squared over r squared minus x squared, which is r over square root r squared minus x squared. Does that make sense?
Yeah, thank you.
Okay, so then we multiply. So this is 2 pi square root r squared minus x squared times r over square root r squared minus x squared dx from 0 to r. These cancel out, so it's r dx from 0 to r. So that's rx 0 to r, which is r squared minus 0 times 2 pi. Oh, multiply by 2. Because remember, I did times 2 over here. So this is 4 pi r squared. Does that make sense? I think I did that a little bit too fast, but...
So we always do integral of 2 pi r arc length, right?
Yeah, 2
For
pi r
surface
dl.
area.
For surface area, yeah. 2 pi r
Right.
dl.
So we just find the arc length and then plug it in,
Yeah, so we find our
right?
dl. We can, whether we want a dy or dx is depending on how you're moving your... In this case, we're moving it across the x-axis, so I found it in terms of dx. That's our dl. And then find your r, and then 2 pi r dl.
And r and was this y? Or was
In this case, yeah.
or because the okay, because
Well,
the radius of the sphere, right?
yeah, yeah. Well, it's, yeah,
Okay.
because it's, we have the half circle, and we're revolving this, so we're making circles this way, right? And so your r1 is just your y, but since we're moving across this way, we need it in terms of x. So r squared minus x squared, square root of that. Does that make sense?
Yeah.
Okay, cool.
And it's times 2 because we're doing the whole, like the other side, right?
Wait, what did you say? Sorry. Yeah, because we're doing only one half of... If we didn't do times 2, we would only be doing this half.
We're doing from 0 to r.
Yeah,
Right, okay.
yeah, because I went from 0 to r.
Right.
You can also go from negative r to r. It's just more plugging in stuff, so... Okay, that should be everything. Is there anything else you guys want me to do, or are we good?
I'm good, thank you.
Okay, cool.
On the worksheet, it says it has one that says like 29 integral of secant x or cosecant x using integration by parts. So
Uh-huh.
like people are saying that he probably just meant partial fractions. Do you know if he ever taught it by parts, like integrating secant by parts?
He never taught doing that by parts. It's ln,
Okay,
right?
so you
These are
probably,
ln secant x plus tangent x.
yeah.
He told us that that was just a trick. He might have taught you guys the derivation. I'm not sure. Um,
I
do you
think
get...
no one
I don't
remembers
think
doing
he
it
ever
by
did.
parts.
Okay.
Yeah, I think it went partial fractions.
Okay. If we... How would you do it by partial fractions? Because it's only one thing, right? 1 over cosine x. There's only one factor.
Then I think you make it like cosine x or 1 minus sine squared x. Like
Cosine...
1 plus sine x times 1 minus sine x.
Wait, repeat that. Sorry. So you cosine x over 1 minus sine x.
Cosine
Oh,
x or, yeah,
does that...
1 minus sine squared x. And then difference of squares for the
Whoa,
denominator.
wait, that's actually crazy. Oh, that might work.
Yeah.
I don't know if he taught you that.
And then for 27,
Mm-hmm.
it's the equation for continuous growth and decay
Yeah.
using a derivative. What's the statement for that?
Okay, so the definition for continuous growth or decay is the rate of change of y is proportional, right? So it's times some constant. It's proportional to the value of y. So you say for continuous growth slash decay, the rate of change of y, maybe in parentheses put dy dx, is equal, or no, not equal, proportional to the value of y. And then you just solve this, right?
Okay, thank you.
Okay, so that's that. And then we wanted to do the one by parts. Let's see. Okay.
But you don't have to do it. I think I know.
Okay.
It was more just I couldn't figure out if it was parts or partial fractions.
Oh, I see what you're saying. Yeah, I think he means
Wait.
partial fraction. So
So do we do it by partial or parts?
partial. So what you would do
Okay.
is get 1 over cosine x, turn that, multiply top and bottom by cosine x. Then cosine x over cosine squared x, which is equal to cosine x over 1 minus sine squared x, which is equal to cosine x. Wait, even if you do this, how do you, because that'll be a over, which is, if you, so that'll be a minus a sine x is equal to b plus, or plus, because even if you do that, b plus b sine x all over is equal to cosine x over. So you need to somehow find a way to solve for a and b by making it equal to cosine x.
Oh wait, did it like use sub on the wait, let me send it over again. This is Deep Ankar's work. He did it like u subs, like make sine x into u and then cosine into du.
Huh. Okay. Make sine x into u. Alright, let me see this. So we made cosine squared x u is equal to, so he gets rid of the, okay, so this isn't that bad. Let me see, is there anything? Yeah, so this isn't that bad, because instead of splitting this into partial fractions, which you can do, you can change it into u here, but instead of doing that, just do it over, so 1 minus cosine x dx, cosine x over 1 minus sine squared x dx, make u equal to cosine x, and then du is equal to, or u is equal to sine x, du is equal to cosine x dx, so that this is u over 1 minus sine, 1 minus u, that's not it, 1 over 1 minus u squared. And then you can, now you can just treat it, now you can do partial fractions with that just fine, and then convert it back after. Does that make sense?
Yeah.
Okay, cool. Okay. Yeah, you guys have to do a little bit more derivation than we did. There's a few stuff I don't recognize, but yeah. Any more questions? Okay, cool.
Good.
I will maybe do a final review for the other finals, but yeah. Okay. See you guys.